Hello everyone, welcome to our lecture series on strength of materials of our syllabus. From the last lecture, we have studied about the definition of moment of inertia, we studied the radius of gyration of moment of inertia. Again, we studied about the two theorems. Those theorems were parallel axis theorem and perpendicular axis theorem. And then we went through the moment of inertia of some basic plane figures. Okay, just to revise it once again, let us go through the parallel axis theorem. So I will not be explaining about the parallel axis theorem here because I have already explained that to you in our previous lecture, but just we'll go through the formula over here. So what is the formula of parallel axis theorem here? IAB is equal to IG plus A square. So where is AB? So you can find here A, you can find here B. So line joining this A to B is AB. So this line or this axis is axis AB. What is IG? IG is the axis passing through the centroid. If G is centroid, the axis passing through the G, that is axis XX, as you can see over here, this X and this X. The axis joining these two X is our IG or IXX. Okay, what is A? A is the area of this section and H is the distance between the two axes. Which two axes? The axis about whom we have to find out the moment of inertia, and the axis which passes through the centroid. Remember here, it is not always mandatory or compulsory that the axis around which we have to find the moment of inertia, that is IAB, should be horizontal. It can be vertical also. Suppose if we consider this as axis AB and if we consider this as axis IYY. So if any axis which is parallel to the centroidal axis, we can find the moment of inertia about that axis. Remember that. Then what we studied about the perpendicular axis theorem. In perpendicular axis theorem, we found the moment of inertia about the polar axis. So what was polar axis? Polar axis was that axis which passes through the plane through that point. Now after that we have the formula of different different plane sections. First of all, we have the formula of rectangular section. We have the formula for horizontal central axis IXX. It is BDQ upon 12, where B is breadth or width of rectangle and D is depth or height of rectangle. Then we have the formula about vertical centroidal axis, and it is IYY is equal to DB cube upon 12. X is horizontal axis and Y is vertical axis. For hollow rectangular section, B was the breadth of outer rectangle, B1 was the breadth of inner rectangle. In the same way, D was the depth of outer rectangle and D1 was the depth of inner rectangle. And using these two dimensions, we had the formula of IXX and IYY. Then we studied the formula of moment of inertia of the circle. The formula for moment of inertia of the circle about x-axis and y-axis is same. That is how much IXS is equal to IYY, and that is pi by 64 d raised to 4. Okay, please note this formula. Please write this formula in your notebook because we will need them. Okay, then we had the formula of hollow circular section. If capital D is diameter of outer circle and small d is diameter of inner circle, we have IXX and IYY equal to pi by 64 d raised to 4 minus d raised to 4, that is capital D raised to 4 minus small d raised to 4. Okay, here also as in circle we have the moment of inertia about horizontal axis and vertical axis as same. Okay, then we studied for the semicircle. Now for semicircle, our IXX was 0.11 r raised to 4 and IYY was pi by 120 at d raised to 4. Remember here that there is a slight difference about the center of gravity here. So what difference is there in the semicircle and circle regarding center of gravity? Let us see. So in semicircle, in particular this kind of semicircle, the centroid will lie on the vertical axis. Okay, it will lie on this y-axis which passes through the center. So what I want to say is that this y-axis will bifurcate the semicircle in two equal parts. So, or what we can say, this semicircle is symmetric about y-axis. But remember, this semicircle is not symmetric about x-axis. Okay, so it is not symmetrical about this horizontal axis. We have some distance from this line or the base of the semicircle to the horizontal centroidal axis. Remember, this axis which passes through C is the horizontal centroidal axis. The horizontal axis passing through C is what? It is the horizontal centroidal axis, and there is some distance from the base to this axis, and the distance is how much? It is equal to 4r upon 3 pi. Okay, how much it is? It is 4r upon 3 pi, and that distance is same when you look at the quarter circle. Okay, you can find here 4r upon 3 pi, and you will also find 4r upon 3 pi at this side also. Okay, so for quarter circle, your vertical central axis will pass through center of gravity in this way, and your horizontal central axis will pass through this way. So from this line, the distance of the horizontal central axis is 4r upon 3 pi, and from this line, the distance of vertical central axis will also be equal to 4r upon 3 pi. So for quarter circle, we will have Ixx and Iyy as equal, and that will be equal to 0.055 r raised to 4. Okay, then in case of triangle, we studied the moment of inertia about x-axis, that is horizontal centroidal axis. We studied about the moment of inertia about y-axis. Then we studied about the moment of inertia about the axis passing through the base and the axis passing through the apex. But here also, for a regular triangle figure, what we have this center of gravity lying on the vertical axis, but the distance of the center of gravity from the base, or the distance of the horizontal centroidal axis from the base, is h upon 3. What is h over here? H is the height of triangle. And what is b? B is the base of triangle. Okay, I think now you are clear with those formulas. Okay, if you are not yet written these formulas, please write it down, because we will need these formulas in the numericals, which will start from now. Okay, now let's go through our first numerical. So what is our first numerical? Calculate the moment of inertia. Remember, what is mi over here? Mi stands for moment of inertia of rectangular section having dimensions 150 mm into 350 mm about its both centroidal axis. So remember, the first important thing that you have to do while you are solving the numericals of moment of inertia, you have to find the section. Means what? You have to first of all find what kind of plane or what section is asked. So here the section asked is what? The section asked is a rectangular section. Okay, then to get a better clarification, what we have to do? We have to draw a rectangle. Remember, drawing a rectangle is not compulsory in examination, but it can be expected from the examiner. Okay, it is not compulsory, but examiner expects it. Okay, and you will also get a better clarification if you draw the rectangle. Okay, so you have drawn the rectangle. We had the section, which is a rectangular section, and we have drawn it over here. Then the rectangle section has a dimension. So after drawing, the work is just half done. We have to give the dimensions. So what dimension is given? The dimension is 150 mm into 350 mm. When dimension in this fashion or this style is given, the first value of dimension is of the breadth or the width of rectangle. So what is 150? So 150 is width of rectangle, and the second value of the dimension is of height or depth of rectangle. So what is 350? 350 is depth of rectangle. Okay, so now you are clear about the rectangle, the concept of rectangle. Now moving forward, What they have asked us to find out? They have asked us to find the or to calculate the moment of inertia about both the centroidal axes. Remember, there will be two axes. There will be two centroidal axes for a rectangle. One will be the vertical centroidal axis and other will be the horizontal centroidal axis. Okay. So when the word axis, AXES comes, or when both is written, what you have to do, you have to calculate moment of inertia about axis XX and YY. Remember that AXES, if it is given, then you have to find IXX and IYY. Okay, so we will write the given, width is given or the breadth is given, it is 150 mm, depth is 350 mm, and from this what we have to find IXX and IYY. Okay, I think you are clear when you have to find IXX and IYY. Once again I will tell you, when you have to find IXX and IYY, when it is particularly mentioned in question that you have to find the moment of inertia about both central axes, then and then only you have to find out IXX and IYY. Suppose the word both is not included in your question. Suppose the word both is not included in your question and just the word AXES, access, comes, then also you have to find moment of inertia about IXX and IYY. Why? AXES is plural of AXIS. Axis is plural of axis. When word axis comes, they means plural, that is two terms. They want us to find the moment of inertia about two axes. Remember this. Okay? Then moving forward, now how to solve? We have the formula for IXX of a rectangular section, which you must have written it down, and the formula is BD cube upon 12. So B is 150 mm, D is 350 mm. So putting those values in the formula, the values of B and D in the formula, we will get the value of IXX. So IXX, after putting those values in calci, we'll get the value of IXS as 5535.9375 into 10 raised to 6 mm raised to 4. What is mm raised to 4? Mm raised to 4 is the unit of moment of inertia. Remember that we have studied that in our first lecture of this particular topic. Okay, are you clear with IXX? Once again, the formula for IXX, how we have to find IXX? The formula for IXX is BD cube upon 12. The value of B is 150 mm. Value of D is 350 mm. Putting those values and dividing it by 12, we will get IXS as 535.9375 into 10 raised to 6. So, sorry. Some of you might be wondering why I have written 4 digits after this decimal point. It is okay if you write 2 digits, but it will be better if you write the 4 digits, because the answer will be more accurate then. Okay, now we have done with IXX. What is remaining? Now the value of IYY is remaining. So how we will find IYY? The formula of IYY, we have it as dB cube upon 12. It is just a change of places of B and D. So it was BD cube upon 12 in IXX and it is dB cube upon 12 in IYY. So when we put those values, the value of D is 350, value of B is 150. So putting those values in a calci, we will get IYY as 98.4375 into 10 raised to 6 mm raised to 4. Okay, so what is IYY? IYY is 98.4375 into 10 raised to 6 mm raised to 4. It is a simple numerical. You have to just write the formulas and put those values. Okay, so in such a way we have found out IXX and IYY. Okay, it is a simple numerical. Remember that the numericals from this topic will be asked for 4 marks. Okay, this numerical was never asked. It is just for beginning. Now let us go through the second numerical. What is second numerical? Here we have to calculate. Second numerical is calculate the moment of inertia of a circular section. Remember, I will underline which section they have asked. A circular section. having 250 mm diameter about both its centroidal axis. Again, both end axis has done. Okay, again what we will do, we will carry out the same procedure. We will first of all draw a circle. Okay, then after drawing the circle, what diameter of the circle is given? The diameter of circle is given as 250 mm. We will write it down. D is equal to 250 mm. And what they have asked us to find out? They have asked us to calculate moment of inertia about its both the central axis, that we have to find out Ixx and Iyy. Here also we have to find out the moment of inertia about horizontal central axis and vertical central axis. Okay. Now, in case of a circle, the moment of inertia about horizontal central axis and vertical central axis is same. The formula is same, and that is equal to Ixx is equal to Iyy, and that is equal to pi by 64 d raised to 4. So what you have to do, you have to just put the value of d in that given formula, and then you can find out the values of Ixx and Iyy. Okay, so Ixx is equal to Iyy, and that is equal to 191.7476 into 10 raised to 6 mm raised to 4. Okay, it is a very easy formula. Remember, what you have to do, you have to just write the formula, which is equal to pi by 64 d raised to 4. You have to put the value of d in the formula, and then you will get the values of Ixx and Iyy. Okay, next. Now I'm going to the third question. Sorry. So what is third question? A steel pipe has external diameter 22 mm and thickness of metal is 3 mm. Calculate the moment of inertia about one of its centroidal axis. Okay. Now first of all, what we will do? We will find the section. I have underlined it first only. The section given here is a steel pipe. Remember, you have seen a pipe. So how is pipe? Pipe is hollow in section, and when the word diameter comes, it tells that the pipe is circular in section. So the section here is a hollow circular section. So what we'll do? We'll draw a hollow circular section first. Okay. Then what is given? The external diameter is given. So external diameter from here to here, from this end to this end is our external diameter, and its value is given as 22 mm. Again, what else is given? The thickness of metal is given. What is thickness? Thickness is the distance from this point to this point. Okay, or it can be from this point to this point. Okay, you will learn how to measure the thickness of various equipments or various machine parts in your EME syllabus. Okay, now here remember again what they asked us to calculate. They asked us to calculate the moment of inertia about one of its centroidal axis. So it is okay to calculate moment of inertia about just one axis. So while writing given, and to find, what we will write, we have external diameter, which is denoted by d, and that is equal to 22 mm. We have thickness, which we are denoted by t, and that is equal to 3 mm. And what we have to find? We have to find moment of inertia about only one axis. In this case, we will take it as a horizontal central axis, and we will denote it as Ixx. Okay, so what we have to find over here? We have to find the value of Ixx. Okay, we have a hollow circular section, and we have to find Ixx. So what is the formula for Ixx for a hollow circular section? The formula for Ixx for hollow circular section is pi by 64 capital D raised to 4 minus small d raised to 4. Now remember here in this question what we have outer diameter, that is we have capital D. What we don't have this small d. What is this small d? This small d is the inner diameter of the circle. So from this figure we can have a relation of capital D and small d. How? We have outer diameter. Okay, and we have thickness. Now when we subtract thickness 2 times from the diameter, we'll get the inner diameter. Okay, are you getting what I'm trying to say? See, this distance and this distance, if it gets subtracted from this whole distance, we'll get distance from this point to this point. That is, we'll get the distance of, or we'll get the dimension of inner diameter. So what it implicates? It implicates that small d is equal to capital D minus 2 into t. So small d is capital D minus 2t. Why 2t? This t, one thickness, this t, second thickness. So 2 times thickness is subtracted from the outer diameter. So outer diameter is 22, thickness is 3. So 22 minus 2 into 3, we will get inner diameter as 16 mm. Now we can use the formula. So using the formula, pi by 64 capital D raised to 4 minus small d raised to 4, we'll put the value of we'll take the value of capital D as 22. We have calculated the value of small d as 16. Putting these values, we will get the value of Ixx, and that is equal to 8.282 into 10 raised to 3 mm raised to 4. Okay, remember here that this is not a straightforward example. The value of dimensions are not directly given. We have to first find a dimension and then we have to use the formula. Just one dimension is given, outer diameter is given. Here we require inner diameter also. Thickness is given. From the relation of thickness, outer diameter and inner diameter, first what we will do? We will calculate inner diameter and then we will use the formula, which is pi by 64 capital D raised to 4 minus small d raised to 4, and then we will calculate Ixx. Okay, now in this case also, in the case of hollow circular section, Ixx is equal to Iyy. But as they have asked us to find moment of inertia about only one centroidal axis, we have taken here Ixx. Remember this. Okay, now let's go through our third numerical. Now let's go through our fourth numerical. So what the fourth numerical states? Calculate the MI, that is moment of inertia, of a semicircle of diameter 190 mm about its both centroidal axis. Okay, so from the last 3 examples, you are now clear what we have to first look for. What we have to first look for? We have to first look for the section. So what is the section over here? Semicircle. Then what we will do? We will draw the section. We will draw the semicircle. Then what we have? We have dimension. One dimension of the semicircle is given. The diameter of semicircle is given, and that is equal to 190 mm. Okay. And what they have asked us? They have asked us to find moment of inertia about both the centroidal axis. So in this case, what we have to find? We have to find Ixx and Iyy. Okay, so in given, I have written D. So what D denotes? D denotes diameter of semicircle. Now in given only, I have found out the value of R. What is R? R is the radius of semicircle. Remember, in the last 2 examples of circle, first was of solid circle, second one of hollow circle, we have not found the value of R. But in this particular example, we are finding the value of R, because the value of R is essential when the question comes on semicircle or quarter circle. Okay, because the formulas that we have learned of semicircle and quarter circle are in the terms of R, means they are in the terms of radius. So in case of semicircle and quarter circle, we have to find the value of radius. So how much is the radius? Radius is half of diameter. So diameter is 190. 190 divided by 2, we will have radius as 95 mm. Okay. Now moving forward, what is Ixx? Ixx, that is the formula for moment of inertia about horizontal centroidal axis of a semicircle, is 0.11 r raised to 4. Okay, as I have told you earlier, this formula comes with r, it comes with radius. So we have found radius. Okay, so Ixx is how much? 0.11 r raised to 4. So putting the value of radius in that formula, we can find the value of Ixx, and that is equal to 8.9595 into 10 raised to 6 mm raised to 4. Okay, using the formula directly, taking the value of a radius from here, we will get the moment of inertia about horizontal centroidal axis. Okay, now the work is just half done. We have just found the value of Ixx. Again the value of Iyy is remaining. What is the formula for Iyy? Now the moment of inertia about vertical central axis for this type of semicircle is pi by 128 d raised to 4. Now we have the value of d as 190 mm, which is given in the question. So putting this value of diameter in this formula, we will have pi into 190 raised to 4 divided by 128. So from that we will get Iyy as 31.9855 into 10 raised to 6 mm raised to 4. Okay, now from this we can find the value of moment of inertia about vertical centroidal axis. Remember, in case of semicircle, the values of moment of inertia are not same for x and y. They are different. So we have to use the different formula for Ixx and Iyy. So for Ixx in such kind of semicircle, the formula is 0.11 r raised to 4. And the formula for Iyy in such kind of semicircle is pi by 128 d raised to 4. Putting those values of diameter and radius at their respective in their respective formulas, you'll get the values of Ixx and Iyy. Okay, I think you are clear with this numerical. Now let us go to our next numerical. Our next numerical, the fifth numerical. What it states? Determine the mi, that is moment of inertia, and radius of gyration of quarter of a circle of radius 600 mm at its own axis. Okay, as we have discussed earlier, what should be our strategy to find the section? So what is section over here? Quarter of a circle, that means quarter circle. So what we will do, we'll first draw a quarter circle. Okay, so what they have given the value of radius. So what is the value of radius? The value of radius is given as 600 mm. And what they have asked us, they have asked us to find out not just moment of inertia, but they have also asked us to find out the radius of gyration. But instead of using the word radius of gyration, they have used the word radii of gyration. Why? Radii is plural of radius. They are expecting us to find the radius of gyration about x-axis as well as y-axis. Okay, and here also they have written about own axis, axes. That is the plural form of axis has come. So what we have to find? We have to find moment of inertia about x-axis also and y-axis also. About the two axes we have to find. And radius of gyration, in case of radius of gyration, what we have to do? We have to find radius of gyration about the two axes. That is, we have to find out kxx and kyy. Okay, so in given, you might be wondering why I have written diameter. Remember, diameter will be necessary when we have to find the area of the circle. Why we need to find the area? We will learn that in the course of time. Okay, now when radius is 600 mm, diameter is double the radius. So r into 2, it will give us the value as 1200 or 1200 mm. Now, first of all, what we will do, we will find the value of Ixx and Iyy. Remember the value of Ixx and Iyy for quarter circle is same. The formula for that is same. That is how much? That is equal to 0.055 r raised to 4. Okay, we have learned that in our last lecture also, and you have written that formula. Okay, so putting the value of a radius in this particular formula, radius is 600 mm. Putting that value here, what we will get? We'll get the value of Ixx. So Ixx and Iyy, as both are same, we'll have Ixx is equal to Iyy, and that is equal to 7.128 into 10 raised to 9 mm raised to 4. Okay, again, what we have done, we have written the formula of Ixx and Iyy. The formula for Ixx and Iyy for a quarter circle is same, and that is equal to 0.055 into r raised to 4. The value of r. R is what? R is radius is 600 mm. It is given in question, and we have written under given heading. So putting that value in this formula, we will have Ixx is equal to Iyy, and that is equal to 7.128 into 10 raised to 9 mm raised to 4. Okay, now we are done with moment of inertia. What is remaining in this question? The radius of gyration is remaining. So what is the formula for radius of gyration? Kxx is equal to square root of Ixx upon a. Okay, Kxx is how much? Square root of Ixx upon a. Now we have Ixx here, we have found it over here. What is the term that we don't know in this formula? We don't know the value of a. We don't know area. So the area of what we have to find? We have to find the area of quarter of a circle. Remember, the section is quarter of a circle. Quarter means how much? Quarter means 1/4 of a circle. So area of quarter circle will be area of 1/4 circle, or area of circle divided by 4. Okay, what is the formula for area of circle? It is equal to pi by 4 d square. When we divide this pi by 4 into d square by 4, what we will get? We will get the value of quarter circle. Okay, the value of d, which is 1200. Putting that value in this formula, we will have the area of quarter circle, and that is equal to 282.7433 into 10 raised to 3 mm square. Remember, you have to write the unit of area as mm square. Don't get confused between the unit of area and the area of moment of inertia. The unit of moment of inertia is mm raised to 4, but the unit of area is mm square. Remember this. Now again, what we were doing, we were finding the value of kxx. Now to find the value of kxx, kxx is how much? Kxx is equal to square root of Ixx upon a. We have the value of Ixx, we have the value of a. We'll put that in the formula, we will get the value of kxx. And kxx is how much? Kxx will be equal to 158.777 mm. Remember that unit of kxx, that is the unit of radius of gyration, is mm. Okay, so in this particular example, what we have found? We have found moment of inertia, we have found area, and again we have found the radius of gyration. Okay, but again the work is half done. Why? We have just the value of kxx, yet we have to find the value of kyy. Now remember here, for quarter circle, Ixx and Iyy are same, area is same, so kxx will be equal to kyy. So that will be equal to 158.777 mm. Okay, I think you understood this example. Now the last example of today's lecture, the sixth example. Okay, remember which sections we have covered? We are in the first question we have covered rectangle. In the second question we have covered a circle. The third one we have found about the hollow circle. Then we had a semicircle. Then we had a quarter circle. In this question, we are dealing with another section. Which, let us see. What is the question? An equilateral triangle has base 120 mm, calculate MI, that is calculate moment of inertia about centroidal horizontal axis. Also calculate radius of gyration about same axis. Okay. Now again reading the question, what will be our focus? To find the section. So what is section given over here? The section given in this question is an equilateral triangle. So what we'll do? We'll draw an equilateral triangle. Okay. Then what is given? Let us go through what values are given. The base of this equilateral triangle is given. So what is the value of base of this equilateral triangle? It is 120 mm. Okay, so the value of base is 120 mm. Again, what they have asked us to find out? They have asked us to calculate the moment of inertia about horizontal axis. Remember, only they have asked us to find out about one axis only, and that is the horizontal axis. And also we have to calculate the radius of gyration about same axis. So we have to find Ixx and Kxx. Remember. Now what is given? We are given with the value of B. B is the base of the triangle, and it is 120 mm. What we have to find? We have to find Ixx and Kxx. Now you know that the formula for Ixx is bh cube upon 36. So to find moment of inertia, we need to find the value of h. Remember, we just have the value of b in this question. We don't have the value of h. So the first task will be to find the value of h. Just b is given and the type of triangle is given. Using this logic, we have to find the height of an equilateral triangle. So you have studied in your school days that the height of an equilateral triangle is root 3 by 2 times the base, or root 3 by 2 times the side. Okay, so the base is denoted by b, so h is equal to root 3 by 2 times b. So root 3 into 120 by 2, you will have h as 103.9230 mm. So here we have found the value of h. H is what? H is the height of rectangle. H is the height of triangle. Okay. Now what we have to find? We have to go and find the value of Ixx. So the formula for Ixx of triangle is bh cube upon 36. Now the value of b is given in the question. We have found the value of h. So putting those values in the formula, we will have the value of Ixx. So Ixx is equal to 3.7412 into 10 raised to 6 mm raised to 4. So in this way, what we have done, we have found the value of Ixx. Then what else is remaining? Now again we have to find the value of Kxx. That is, we have to find the radius of gyration about the horizontal centroidal axis. So you know the formula of Kxx. So we know the formula of Kxx as we have studied, as we have learned, as we have gone through it in our last numerical. What is Kxx? Kx is equal to square root of Ixx upon a. So what is a? A is area of the section. Now the section over here is a triangle, so we have to find the area of triangle. So area of triangle A is equal to half into base into height. You have learned this formula in your school days. What is the formula for area of triangle? Half into base into height. I have written over here it as b into h by 2. Same thing. Okay, we'll put the values of b, that is base, and height in this formula, and we'll get the value of a, that is area. So area over here will be 6.2353 into 10 raised to 3 mm square. So what we did here, we found the value of area. So we have now Ixx, we have now area. So now we can find the value of Kxx. So we'll use the formula Kxx is equal to square root of Ixx by a. We'll put those values over there, and we'll have Kxx equal to 599.9955. It is approximately equal to 600 mm. So what we will have? We will have the value of Kxx. The value of Kxx is equal to 600 mm. Okay. Once again, remember what we have done. First of all, the height of triangle was not given. What we did? First, we found the value of the value of height of the triangle. Then what we did, we found the value of moment of inertia about the horizontal central axis. Why horizontal axis? Because it was given in question to find the value of horizontal axis only. Then what we did, we found the area. Why area? Because to find the value of radius of gyration, we need area. So what we did, we first found the area of the triangle. What is formula for area of triangle? Half into base into height. How? That you have studied in your school days. Okay. Now we have area. We have moment of inertia about horizontal central axis, that is Ixx. Using these two values and putting them in the formula of Kxx, that is the formula of radius of gyration, we have found the value of radius of gyration, and that is equal to 600 mm. Okay, so in this particular lecture, what we did, we gone through 6 different numericals, and those numericals were of basic type. Okay, this particular numerical was asked previously in examination. Okay, that was asked for 4 marks. Okay, remember this, the numericals from moment of inertia will be asked for 4 marks only. House, whatever the size of that your answer may be, whether that numerical will take 4 steps, 2 steps, or even 40 steps, in any case that numerical will be asked for 4 marks only. In very rare cases it happens that the numerical will be asked for 6 marks. In most of the times the numerical will be asked for 4 mark only. Okay, I think you are clear with today's numericals. If you have any doubt regarding the numericals or regarding the content that we have studied under the heading of moment of inertia, please let me know. In the description we have put the link of our channel, of our Telegram channel. Please go to it, post your questions over there, and we will give the answers of that questions in that particular channel only. Okay, okay, that's all for today. Thank you.